This segment is on the flow of blood through the heart. I'm going to draw a picture of the heart separating the right and the left side. The right side of the heart will draw the atrium and the ventricle. We'll draw the left side of the heart. This is the left atrium, and this is the left ventricle. Okay, the right side of the heart I've drawn blue because the blood that enters into the right side of the heart is deoxygenated. The blood from the superior vena cava and the inferior vena cava flow into the right atrium. The superior vena cava drains the blood from the head and the upper extremity and the upper trunk. The inferior vena cava drains the blood from the lower extremity and the abdominal pelvic region, including the viscera. Once this deoxygenated blood enters into the right atrium, it will flow through a broad opening into the right ventricle. It has to pass through a valve, which is called the AV valve. This valve is made up of 3 different cusps. We call this AV valve the tricuspid valve. And the tricuspid valve is held down by these chordae tendineae, which are attached to these papillary muscles that are attached to the walls of the ventricle. When the right atrium contracts, blood will flow into the right ventricle. When the right ventricle contracts, the blood will leave the ventricle and flow into a major blood vessel called the pulmonary trunk. When the ventricle is contracting, the blood is going to push up against the atrium as well as push towards this pulmonary trunk. At this time, the tricuspid valve will close as the pressure of the blood pushes up against them, forces the blood to leave the ventricle only through the pulmonary trunk. The pulmonary trunk will divide into arteries called the pulmonary arteries. So we have the left pulmonary arteries and we have the right pulmonary arteries. The left pulmonary arteries go to the left lung, the right pulmonary arteries go to the right lung. At the lung, the blood picks up oxygen and the blood becomes oxygenated and appears to be red. From the lungs, there will be 2 pulmonary veins returning from the left lung and 2 pulmonary veins returning from the right lung, bringing this freshly oxygenated blood back to the left atrium. When the left atrium contracts, blood moves through a large opening into the left ventricle. As it does so, it has to pass through a valve that has 2 cusps. This is the left atrioventricular valve, or the bicuspid valve, and more commonly known by clinicians as the mitral valve. When the left ventricle contracts, the blood will leave the ventricle through a major blood vessel called the aorta. The aorta has an ascending branch, an arch, and a descending branch. The descending branch can be divided into the thoracic aorta and the abdominal aorta. The thoracic aorta is above the diaphragm. The abdominal aorta is below the diaphragm. The aorta will branch repeatedly to become small blood vessels called capillaries, and it's in these capillaries where the exchange of gases occurs. And so oxygen will be deposited into the tissues and will leave the blood. This is going to occur at any active tissues in the body. Once oxygen has diffused out of the blood and into the tissue, the blood now appears more blue in color and is deoxygenated. The vessels carrying the deoxygenated blood will merge together to form veins. The veins will merge together to form larger and larger veins, and eventually the blood will then return to the right side of the heart through the inferior vena cava and the superior vena cava, and the cycle will start all over again. Between the right ventricle and the pulmonary trunk is a valve that is called a semilunar valve. It's a semilunar valve because it looks like a half moon shape, and we call that the pulmonary valve. And on the left side of the heart, between the left ventricle and the aorta, is another semilunar valve, and this semilunar valve we call the aortic valve. When the blood leaves the ventricles and enters into the pulmonary trunk and the aorta, eventually the pressure inside the aorta and the pulmonary trunk will be greater than the pressure inside the ventricle. The blood then will start to push back towards the ventricles, and at this time those semilunar valves are going to shut to prevent the regurgitation of blood from those major blood vessels back into the ventricles. This ends the segment on the flow of blood in the heart.